Do you own a bottle of perfume or cologne you simply can't resist using each day? Are you loyal to a particular brand of laundry detergent used to keep those clothes clean and fresh? Each of these products, detergent and perfume cologne, contain ingredients called organic solvents. Let's learn more about what an organic solvent is and why they are so widely used in the manufacturing industry. Organic solvents are known as carbon-based solvents. A solvent simply refers to a substance that is capable of dissolving other substances. By being carbon-based, these solvents have carbon atoms present in the structure of their compound. For example, in this diagram, you will see that 6 carbon atoms are present in the organic solvent benzene. This example leads to an important point regarding organic solvents. Their molecular formula, or structure, will always contain a carbon atom and most often a hydrogen atom. Organic solvents can be categorized by their molecular structures. There are organic solvents, such as hexane, that have long aliphatic chains. On the other hand, organic solvents, such as toluene, contain aromatic rings. Diagram 2 provides a great illustration showing the difference between the molecular structures of these two organic solvents. There are numerous organic solvents used in the chemical industry, too many to name and discuss in this lesson. However, we can broadly generalize the physical properties of organic solvents. Let's look at 3 physical properties you are most likely to encounter when working with or handling an organic solvent. Property number 1, volatility. The physical property of volatility refers to the ability or tendency for a given substance to vaporize. Vaporization is related to the physical change of a substance from a solid or liquid into a gas. Most organic solvents are considered to be volatile. In other words, do you know the chemical smell that hits you right in the face when you are opening a can of paint? Well, thank organic solvents for contributing to that smell. Due to volatility, when released into the air, it is not uncommon for organic solvents to emit this often offensive smell. Property number 2, boiling point. In general, organic solvents are known to have low boiling points. A low boiling point should make perfect sense in relation to volatility. Why do you ask? Well, the lower the boiling point, the higher the volatility, or easier it is for a substance to evaporate. Remember to keep this relationship between both physical properties in mind. Property number 3, size and color. Besides having a characteristic smell, organic solvents are known to be clear and colorless liquids. Additionally, they are also known to have low molecular weights, grams per mole. Learning what an organic solvent is and the type of properties associated with these substances is a good way to understand them, but this lesson wouldn't be complete without providing a list of common organic solvents. The physical properties of molecular weight and boiling point are provided in this list. Common applications of these solvents are also provided to illustrate how useful organic solvents are in our everyday living. It is important to address the toxicity to organic solvents if exposure at a certain threshold limit is exceeded. Think of a threshold limit as the point which, if exceeded, can result in a negative outcome to your health or life. Scientists and health professionals have worked diligently to educate everyone on the health risks associated with exposure to certain organic solvents. For instance, organic solvents such as benzene, carbon tetrachloride, and trichloroethylene are classified as carcinogens. A carcinogen is another way to say that a substance is cancer-causing. Other health risks include reproductive hazards and neurotoxicity. Thus, threshold limits have to be set to ensure we are protected from experiencing these nasty health effects. It is worth noting that monitoring toxicity is commonly practiced in certain workplaces, where exposure to different organic solvents above the threshold limit is possible. In the case of our everyday products, like nail polish remover or a can of paint, taking a one-time whiff of that awful smell won't necessarily lead to these nasty health effects. Let's review. Organic solvents are known to be a type of carbon-based solvent. These solvents contain at least one carbon atom. Organic solvents can be categorized by differences in molecular structure for each compound. High volatility, low boiling point, a colorless and clear liquid, and low molecular weight are physical properties typical of organic solvents. Examples of organic solvents include carbon tetrachloride and acetone. Health concerns, such as reproductive hazards and carcinogenicity, are primarily monitored in the workplace, where exposure to organic solvents above the threshold limit is possible.